Good morning, all of you. Okay, welcome back to Lakshya Academy YouTube channel. Okay, this is the part 8 of digestion and absorption. Okay, in the previous part 7, I explained some points related to liver. Okay, in this part, we will focus on functions of liver. It is important 4 marks question, and we can also expect some important bits from this topic. Functions of liver. Okay, that we are going to focus in this part 8. Functions of liver. Okay, let us recall some of the points that were discussed in the previous video. Okay, what is the largest organ in our body? The largest organ is liver, and largest in our body, inside our body, and largest gland is also liver. What is the weight of the liver? 1.2 to 1.5 kilograms. Where is our liver located? It is located in the abdominal cavity. Okay, liver. How many lobes are there in our liver? Two lobes. What are they? Right lobe and left lobe. Which is the larger one? Right lobe is larger than the left one. Okay, each liver lobe consists of some structural and functional units. What are they? Hepatic lobules. What is the shape of the hepatic lobule? Hexagonal shape. What do hepatic lobules contain? Okay, each hepatic lobule contains hepatocytes. How are they arranged? They are arranged in the form of cords called hepatic cords. And what do these hepatocytes produce? They produce bile juice. Okay, the bile juice is carried by hepatic ducts. Hepatic duct is common hepatic duct is joined by cystic duct and form common bile duct. The common bile duct joins with another duct. What is that? Pancreatic, and form hepatopancreatic duct, which opens into the duodenum. At that opening, there is a sphincter called sphincter of OD. Very important one. It was also asked in previous NEET. Now come to this part. Okay, liver performs a variety of functions. What are they? Synthesis, storage, and secretion. Okay, liver performs a variety of functions. Okay, triple S. One is synthesis, one is storage, and another one is liver secretes some substances. Liver secretes some substances. Liver synthesizes some substances, and liver also stores some substances. Okay, now let us start the functions of liver. First point, very important, 4 marks. Okay, liver secretes a juice called bile juice. What is the color of the bile juice? Yellowish green in color. Okay, liver secrete one of the digestive. We have different digestive juices. Okay, like we have sapota juice, apple juice, like that in our body also there are some juices. In our mouth there is a salivary juice. In our stomach there is a gastric juice. Okay, in the liver produces pancreatic juice. Sorry, pancreas produces pancreatic juice. Liver produces bile juice. Intestine produces intestinal juice, also called as succus entericus. These are very important. These are all different digestive juices. Okay, liver secreted this. Okay, bile juice is produced by the liver. What is the color of it? Yellowish green in color. Okay, liver does not contain any enzymes. Sorry, bile does not contain any enzyme, but it contains bile salts, bile pigments. Okay, these are present in the bile juice. I will show you here. Okay, in this flow chart. Okay, bile. Okay, bile has no enzymes. The digestive juice is the only digestive juice without enzymes is the bile. Okay, bile has bile pigments. What are the bile pigments? Bilirubin or bilirubin and biliverdin or biliverdin. Okay, bilirubin, biliverdin are the bile pigments. How are they formed? I will discuss it later. Next, the color of the bile, yellowish green in color. What are the salts present in bile? Salts are very important. They help in emulsification of fats. They also help in the activation of lipases. What are the bile salts? Glycocolate, taurocolate. Glycocolate, taurocolate. I repeat again, this is the composition of bile, earlier billion, composition of saliva, composition of intestinal juice, composition of gastric juice. This is the composition of another digestive juice, that is bile. Okay, bile has no enzyme. This is the only juice without enzyme. Bile has pigments. What are the bile pigments? Bilirubin and biliverdin. And what is the color of the bile? Okay, yellowish green in color. What are the salts present in the bile? Bile has glycocolate and taurocolates of sodium and potassium. We come back to this slide. Okay, right. Liver does not bile does not have any enzymes, but it contains bile salts. What are they? Sodium glycocolate and taurocolates of sodium and potassium. Glycocolate and taurocolates of sodium and potassium. These points are not given in NCERT, only given in state textbook. Our next point, bile contains bile pigments. As I told you, bile contains bile pigments. What are they? Bilirubin and biliverdin. Okay, bile contains bile pigments, bilirubin. How are they formed? Bile pigments, there are different pigments in our body. Hemoglobin pigment is present in our RBC. There is another pigment in our skin, that is melanin pigment. One of the pigment present in the leaves, that is the chlorophyll pigment. Like that, in our bile also consists of, there are pigment. What are we call bile pigment? Okay, how are these bile pigments are formed? Bile pigments are formed by the breakdown of hemoglobin of RBC, old RBC destroyed in the body. Bile pigments are formed. Okay, how in our body every day 10 into 10 to the power of 12 RBC are destroyed. 10 into 10 to the power of 12 RBC are destroyed. Old RBC. Our lifespan of RBC 120 days. Lifespan of RBC is 120 days. After 120 days, okay, they become old. Okay, after 60 or 70, after 60 years, we become old. Like that, our RBC, the lifespan is only 120 days. Okay, they live only 120 days. Okay, after 120 days, they become old. They worn out. The worn out RBC. Okay, when we become old, we finally, okay, there is a death. Okay, when after death, our bodies are buried in a burial ground. Like that, in our body also there is a burial ground for RBC. The burial ground for our graveyard of RBC is the spleen. Some extent of RBC are destroyed in our liver as well. Okay, when these old RBC are destroyed in our liver, some pigments are formed due to the breakdown of hemoglobin. Hemoglobin is a respiratory pigment, red color pigment. Okay, bile pigments are formed by the breakdown of hemoglobin of old RBC or worn out RBC. After working 120 days, the RBC become old and they are broken down and form bile pigments are formed. Okay, liver play. That's about the bile composition. Bile has no enzymes. Bile. Okay, where is this bile constant? The bile is concentrated in the gallbladder. Okay, bile has no enzyme. Bile has bile pigments. Bile salts are present. Bile pigments are bilirubin and biliverdin. Bile salts are taurocolate and glycocolate. Bile pigments are bilirubin and biliverdin. How are these bile pigments are formed? Due to the breakdown of hemoglobin of old RBC or worn out RBC in our liver. Okay, another important point, liver plays a key role in carbohydrate metabolism. Here, very new terms. You are not familiar with these terms. You come across first time. These are very, very important, confusing terms. So concentrate on, focus on these four terms. Very, very important. Liver plays a key role in carbohydrate metabolism. What are they? Glycogenesis, glycogenolysis, gluconeogenesis, and lipogenesis. What are they? Glycogenesis, glycogenolysis, gluconeogenesis, and lipogenesis. We go ahead. Let us see what are these four in a equation, in the form of equation. What is meant by glycogenesis? Genesis means formation. Here, what is formed? Glycogen is formed. From where? From glucose. Okay, every day we take rice, we take different types of food item, carbohydrate rich food, we take bread like that. Okay, that rice consists of starch, that is starch is finally converted to glucose. Okay, when there is excess glucose in our body, that excess glucose is converted to glycogen, which is called animal starch. Plants convert glucose into starch and they store in the leaves. You learned in how we can also test the presence of starch in the leaves. Like that, in our body also, like plants are converting excess glucose into glycogen, a starch. Our body, when glucose is in excess amount, it is converted to glycogen, and that glycogen is stored in our liver. Okay, liver is nothing but and it also stored in muscles. Okay, a lot of glycogen is present in our liver. Okay, the formation of glycogen from glucose is called glycogenesis. Glycogen is formed here. That's why it is named as glycogenesis. The opposite reaction is called glycogenolysis. When your blood glucose levels are low, okay, the glycogen in your body, which is converted to glucose, and it comes back to blood. Okay, this is here, lysis means breakdown. Glycogen is broken down to form glucose. This is called glycogenolysis. It is opposite to first one. Okay, this for this first reaction, insulin is important, and for the second one, glucagon hormone is important. Those are secreted by the pancreas and they come to liver and they carry out this reaction. Next one, gluconeo. Neo means new. Gluconeogenesis is a synthesis of glucose from non-carbohydrates other than carbohydrate, proteins and lipids. If glucose is formed from non-carbohydrates like proteins and lipids, that is called as a that is called gluconeogenesis. Neo means new. From new substances, glucose is formed, not from carbohydrate. This is called gluconeogenesis. Next, lipogenesis. When our body, when there are excess carbohydrate, they are also converted to lipid. This is formation of lipids is called lipogenesis. These all are carried out by liver. These are part of carbohydrate metabolism. Okay, now come back to lipid metabolism. Liver plays a role in lipid metabolism as well. Okay, synthesis of cholesterol and production of triglycerides. Cholesterol is a type of fat. Okay, and production of triglycerides, these are carried out by our liver. Okay, next, another important point, deamination of proteins. What is meant by D? D means removal, dehydration. In summer, okay, we lose lot of water from our body. That is called dehydration of water. Okay, here D means removal, amino group. Okay, amino group is removed from the protein. You know that proteins are made up of amino acid. Okay, the amino acid, the word itself telling amino group is present in amino acid. That amino group is removed, NH2 is removed from the amino acid. That is called deamination. Okay, that deamination is carried out by liver, and here NH2 is formed. From that NH2, one hydrogen is added to this NH2, and therefore ammonia is formed. This ammonia is converted to urea via a cycle called ornithine cycle. Ornithine cycle, very very important one. It is also called urea cycle. Urea, generally when I say the urea, okay, urea, kidney may come to your mind. Okay, urea is not formed in our kidney. Okay, urea just eliminated by the kidney. Urea is formed in our liver. Okay, how is it formed? There is one cycle for the formation of urea. Okay, that is called ornithine cycle, otherwise called urea cycle. In this cycle, another not only ammonia, another waste material also removed, that is called carbon dioxide. Carbon dioxide and ammonia combine and form finally urea, and this cycle is called urea cycle, otherwise called ornithine cycle. And that through the blood from liver it comes to kidneys, and kidneys eliminate this urea, and it which goes outside through urine. Every day nearly 25 to 30 grams of urea, okay, is eliminated through urine from our body. Okay, next one, this is the CORI cycle, very important. You will be learning more about this CORI cycle in the coming lessons in the muscular system. The lactic acid, you all know very well about the lactic acid. When you do vigorous exercise, lactic acid is formed in our muscles. Okay, lactic acid formed during anaerobic muscle contraction is converted to glucose via pyruvate. This cycle also takes place in the liver. This cycle is called CORI cycle. I will show you here. This is the CORI cycle. Okay, observe here, this is a muscle. Okay, when you do exercise, okay, because of vigorous exercise, your body is unable to supply oxygen to your body. Okay, your muscles, okay, therefore your muscles carry out anaerobic respiration. Due to anaerobic respiration, glucose is partially broken down to, first glucose is converted to pyruvate. You already learned in botany, that is called glycolysis. Here 2 ATP, there is net gain of energy is 2 ATP molecule, and 2 from these 2 pyruvic acid molecules, they are converted to 2 lactate, otherwise called lactic acid. Pyruvate, otherwise called pyruvic acid. Now this lactate come to blood, and through the blood it goes to liver. In the liver, lactate is converted to pyruvate is converted to glucose. Again, once again it comes back to muscle. Okay, this cycle is called as a CORI cycle. CORI cycle also occurs in our liver. Okay, that's all. Okay, there are some more points, some more functions of liver. I will cover those in the next part. Okay, until then, okay, keep watching these videos and write down notes. Thanks for watching.